knew, but you're also going to need graph paper because we're going to make an XY coordinate axes, or a Cartesian plane, if you will. So the first task I want you to do is draw a circle on your paper. So like on your graph paper, not your tracing paper, right? We're going to check that we know some vocab. So I bet you know what a tangent line is, but I don't know if I would bet on this, but I'm not certain if we know the word secant beyond. When have you heard secant, or what do you know about it?
I heard it in that book that I inverse sine is also known as secant, right? And inverse cosine is cosecant.
So there are applications of secant and cosecant in trigonometry, and actually that circles back to what we're doing today. See what I did there? Circles.
So do we need to draw a circle in here?
Yes, but you can use your shapes template to draw like a nice, easier circle. We will use the compass when we're trying to draw circles of whatever size we want, right? So draw a circle with a line that just touches the circle once. And then draw a line, or you can draw a new circle if you want, or you can use the same circle, but make a line through it that touches the circle twice. Yeah, a chord, but it continues outside. And then draw a circle with a line through it that touches the circle 3 times.
I'll do that. Okay,
Bet. Dude, I went through the drive-thru the other day, and the dude, it was like Wendy's. I was like, all right, can we get 4 for $4? He's like, bet, soda? Like, I was like, wait, what? Are we now using bet in just like day-to-day life?
So, Mr. Hudson,
Yes.
you get the extended cord.
So,
Yes, it is, because my book that I think
The textbook you paid for said so.
Yes.
so if you draw a circle and you have a line through it that touches the circle in 2 different points, this is what we call a secant.
Oh, I need to add a little arrow to tell you it's a line, not a line.
Why did we draw a tangent?
So a line that crosses and touches, or not really crosses, but just clips the circle. Just barely touches. That is what we call a tangent. So when we talk about secant and cosecant in trigonometry, yes, this is where it comes from and relates to. And then to draw a line that goes through the circle 3 times
Easy.
would be impossible unless the line is a curve, which then it's not a line.
Parabola.
Parabola.
It's my favorite kind of line.
All right, so secant, the line that touches at 2 points, right? So moving on, we have this circle C and line L and point P.
If you make a diameter, it would make a right angle, I guess. I think. Connecting C and D.
So if we would like to do this on your tracing, now you don't have to, but the idea here is that if we fold line L through point P back onto itself, like we did in the last lesson, what would we be creating then? We'd be creating the fold that is actually a diameter, right? But then we'd also be making the radius. Yeah. So this would be the perpendicular bisector of line L if it had endpoints, right? If it was just a line segment. But so we would see that fold and we would know that because it's a perpendicular, not really bisector here, but so if you make a circle on your tracing paper, and this is up to you, and you draw a tangent line, and you fold the tangent line through point P back onto itself. So we would fold,
Oh, okay.
then we'd have a fold right here,
A diameter.
right? Making a diameter of our circle, as we talked about, I think 2 days ago. This is 1024. So since we know that's a diameter, we also know that it's a radius. And since we already learned it a couple lessons ago, we know it's perpendicular. Bisector doesn't really matter here. So we know that that diameter would be perpendicular to that line, which we can also then say the radius is perpendicular to that line. The only not fun part about this is you guys already know about tangent lines, and most of this is review, which is probably why we'll end up into 10.2.5 today as well. So, draw this on your paper. It does not need to be tracing paper, it can just be the regular graph paper. So essentially draw a circle with a secant line. Then we're going to label those crossing points A and B. So AB is the chord across our circle, but line, whatever you want to call it, is a secant line, right? If we call line segment AB, if we look at the segment AB, that's a chord. Okay. So if I draw a line from C to A, now this is the annoying thing about our circle template paper. Like there is no way, or not template paper, but the circles template. There's no way to know the exact diameter unless we fold a couple times. Or sorry, the exact center, my bad. So if I draw from C, I'm going to cheat to make sure it's perfect with my crosshairs. From C to B. And I draw C to A. Yeah, it looks like it might be right, but it's a little hard to tell if we, well, how could we tell? Like, what else would we need to know to determine if it's right? Ooh. If we would know, do we remember what we called this yesterday?
Arc, minor arc.
Yeah, that's not wrong, but I'm looking for a different word. It started with an I. The intercepted arc. So if we knew the angle measure of the intercepted arc, or like the arc measure, right, then it'll be the same as the angle C that we open up here. But so Ventura's question assumes that the line is perpendicular to a radius, right? And AB is perpendicular to CA. Right? There's a bunch of assuming there. So Ventura adds, I'm thinking CAB is isosceles. Why would that be true? Oh, because CA and CB have to be radii, because any line from the center to the edge is a radii.
And then you can just fold the triangle in half to find the perpendicular bisector.
Okay. So CBA must be a right angle, she says. CB, wait.
Given what information?
CB, I don't know, she just said it. she's just like, well then, you know, the kids who don't even raise their hand, they just shout out. And you're thinking like, wait.
Oh, this was also in my textbook that I paid for.
It says it's impossible.
It's not impossible. That's not a right angle.
So wait, if this is a right angle, what else would have to be true? So, now, as we've already said, there's a lot of assuming happening here, which is a bad thing. And kids are just like saying stuff. We don't necessarily know that it's true. So, so let's assume again, the line perpendicular to the radius is a secant. What sort of proof starts with like, hey, that's wrong? Proof by...
Contradiction.
So, what we're actually setting up here with this statement, let's assume the line perpendicular to the radius. What they're talking about here is a line that is perpendicular to a radius. Is that a secant? It's a tangent. So what they're saying right here is wrong.
It also could be a secant, though.
Well, so let's test that.
Because, no, I mean, like, that line that you put there is obviously always going to be a tangent.
The purple line or the black line here, AB?
No, okay. But like the purple line's the radius, right?
Yes,
And then
is
you're
A
putting that
radius.
right angle on a line that's perpendicular to the radius. But if you were putting it like closer into the circle,
So you mean like here?
Yeah.
So,
Still be perpendicular.
so it could be perpendicular.
It could
Okay.
be, but it's not necessarily true.
So that's what we're. If it's necessary, like if it's true, it's true, right? So not like a conditional statement, like we talk about sometimes. If this is a right angle, that hurts me to try to draw, and we know that this is isosceles, then this angle also has to be a right angle.
Yeah, that's not a triangle.
And that, yeah, we're.
Wait.
I'm guessing you're saying it in your head because we're saying the same thing, and you're saying wait now.
No, I was like, where you made it like a line triangle?
Langle? An angle? Alright, so this can't happen. So this would be how we could prove by contradiction that secant lines are not necessarily perpendicular to the radius. They could if we draw something like this, right? Ooh, because there's infinitely many radii. Yes. Alright, I think that's everything from this slide.
So like, knowing that they're perpendicular to a line in the circle that we don't know is very helpful.
I wonder if we learn more, if we could figure out how to figure that, like, determine that. On your paper, draw a Cartesian plane, XY coordinate axes. It's called a Cartesian plane. It's the fancy way to say it. It makes you sound smart. That's why I'm going to start using it as you guys like get ready to head towards high school. Because then in high school, you go, guys, we need a Cartesian plane. Yeah, because that's exactly what you'll do.
You're a big nerd.
I mean, pretty sure if you find the right group of people, big nerd is like a compliment. Like when Mr. Estes comes in here and calls us nerds. He's just jealous he doesn't get to teach you guys this. I mean, most science people are also kind of math people, and he's definitely a science person.
Actually, Mr. Hudson, I have a question. In an exponential equation, does the slope change?
In an exponential? Yeah, it's constantly changing.
So it's a odd thing.
So there's really only slope. There's really only slope in a moment, in like at a point, quote unquote. Because as soon as you follow the line, quote unquote, because it's not a line, it's a curve. So yes.
Because we were talking in science, and the
Actually on people and they were wrong.
Hey, I was like, that doesn't sound right. Okay.
And I was like, Connor, you're being a bozo.
No, you didn't say
I
that.
thought that.
You thought that. Well, everyone always thinks that. Come on. It doesn't sound
we
right.
just made a Cartesian.
So our Cartesian plane. Now we're going to plot A, B, and C here.
Oh no, are we gonna have to find circumcenter?
So A, B, and C are cities. Great. We've decided to connect these cities, similarly to most big cities, with a circular highway. Most big towns have a loop around the outside of the major city in the center, and normally there are suburb cities. Well, that's why whenever you go to set up a Cartesian plane, look at the points you're going to graph to see like where you need to have space.
My points fit, I just don't know if the circle will fit.
Ah.
Is a chord.
Oh yeah, it's just two chords.
BC is a chord.
So AB, BC, and AC will all be chords in the circle. We need to find the center.
We have notes on how to find the center of two chords.
Yeah, but we're not
Or how to
really
make the circle.
Or with a triangle. It's called circumcenter. We have this whole like unit about it.
And we weren't very
We're not very good at it.
we were struggling.
Forget whether you need to find the angle bisector or the side bisector.
It's the side bisector. There was a homework question about this.
Cool. Okay. I know how to do it then.
That's why we're on teams. Well, not me.
Wait, for the other.
There are only 3 of us, so.
We're a team.
I heard a wait.
We're all winners here.
Oh, God.
I should really use the compass.
I will tell you, your center should end up at a nice location.
Wait, can I just guess?
No.
Can I just guess?
I mean, you can. Will I tell you if it's right or not? No.
If it's a nice location, like, there's not that many nice locations that we have available. What?
Did you say I realize I'm dumb?
I realized that I'm done a long time ago.
Well, some people realize I'm not so.
Yeah, I know. That's what you call dumb people.
Okay.
No,
I think you're not dumb.
I'm not dumb because it works with what we were talking about.
Is it 2, 3? I don't know. Probably.
Why do you believe that it is
I don't know. I probably did. I did.
Why are you using a discount?
Yeah.
Yes.
Because 2, 3 is a nice point, and I also got that for my first
Oh,
one.
that's wonderful.
Well, I didn't get that. And the reason
Oh,
I
you're silly.
didn't get that is because I haven't finished yet.
I think you've already put through the paper, so it's going to be easier if you put another some paper underneath.
I did it.
Nice. These compasses are so much better.
I know, right?
I got 2, 3. Is that what you guys got?
Yes.
I haven't finished yet, but I think that's
Well,
what
I need to draw the lines. But
All right. So, what lines did we draw to find that center?
I did BC.
perpendicular bisector.
Perpendicular bisectors. So, how did we get the perpendicular bisectors?
I did the more than halfway.
The more than halfway method seems to be one of the
I was gonna
easier
use
to
a
remember.
ruler, but then the values weren't nice.
Yeah, funny how math does that.
See, if we had these for the test that we took, for like chapter 8.
They took Mr. Hall saying, "Do you have any decent compasses?" And I said, "No, all of mine suck." And he said, "Let's order some." I said, "Oh, that's a good idea."
Now what do we do?
Well, if we all agree on 2, 3,
We're all wrong.
I'm not done.
so what would be our radius there of that city highway plan?
It'd be about 5.
About 5.
And when
So
I say
each-
about, I mean exactly.
So each unit is a mile. How long is
And
this
those
highway?
cities are very close to each other.
5 miles.
No, it's
No.
10
Yeah.
miles.
10 pi, so approximately
31.4.
like 31. Yeah, so yeah, those cities would be very close to each other. But hey, cities don't necessarily have to be, well, okay, towns. I was about to say, if you go in certain parts of Appalachia, you'll look like small town, small town, small town.
Yeah.
Okay,
But
Hey.
they've done
now what do we do?
I'm
Aww.
gonna draw the circle around
Could I please have Stella Bernhardt to the office? Stella, please come to the office. Thank you.
I'm debating if we want to do this proof.
Probably wants to get free food.
Dude, I want free food.
All right, so what
That's not
is the point that you guys just found?
Circumcenter.
No, that's
That was the circumcenter.
Is it circumcenter or is it incenter?
It's the circumcenter.
I made the circle. My finger was big enough.
The in-center you make with the angles.
Yeah.
So, the incenter, you just said we use angle bisectors for, and we use perpendicular bisectors for this.
That's how you make the circumcenter. That's its bend.
Yeah, I don't know if I'm going to make us prove this. I'd rather kind of keep moving at a quicker pace.
a great idea.
Good
What?
idea, please.
What are we not going to prove? I want to prove it.
So, this diagram, sorry, no, we would need to draw the diagram. I have it in my book, but yeah, I'd rather just solve a few problems to make sure we understand how to do this.
Great, okay.
All right, so parts A, B, and C here. I bet you guys don't even need 5 minutes for this.
Bird and lemon. CP.
What?
I haven't even.
Yeah, that's not.
Wait, never mind.
Bird and lemon. Yeah.
Well, wait, what's 36 minus 25?
Wait, no. Wait, square root of 11.
Yeah, because 36 minus 25 is 11.
But then, what is angle C?
Well, technically we need to get our calculator that.
Well, then, technically, I think you're gonna need to get a calculator
I don't
out.
know that you know what technically means.
Hey, I wasn't the first one to say it. Actually, I said technically we would need to get our
No, I
calculators
know, I
out.
stopped that.
Yeah, I know.
So I wonder if this is going to help us understand where the heck all that trig stuff we did came
Wait, I
from.
got it. It's tangent to the negative first. No, not tangent to that one. It's cosine
What?
to the negative first.
So what sort of line is PQ?
5/6.
No, it would be sine to the negative.
The long leg.
So what sort of line is PQ?
No, it's cosine.
Okay.
Opposite over hypotenuse is sine.
Yeah, buddy. Oh my goodness, I'm stupid. I was trying to figure out Q and then do 90. Yeah, you're right.
You guys get it.
56.44.
That's what I got.
Great. Get out my calculator.
Are we doing B?
Yeah, absolutely. So wait, what did you guys get? You got radical 11 and 56.4. Sweet. Let's do B.
HDR is 44. GD.
Okay, I'll go for. Well,
Actually, so you guys seemed to ignore my question. Although I'm sure we heard it and didn't mean to ignore my question. Go back to A for a second.
OR is 30.
And GD is 110. Sorry.
Oh, why is it?
Because I want us to go back to A for a second to actually think about where these things came from.
Oh, you wanted us to actually think about that?
So, I mean, you got the right answers. But
Well,
let's
I
talk for a
figured
second about what the heck this means. So, when you had this moment, and I was too slow, but you had this moment where you were saying opposite over hypotenuse is sine. Is sine. Now, I agree, that's correct. But when we talk about what these words mean, what sort of line is PQ? A tangent line, which is one of those like SOHCAHTOA things, right? And when you think about tangent in like SOHCAHTOA, what are you thinking? Tangent of a theta, right, an angle measure, is opposite over adjacent. So we aren't using the hypotenuse length. So here, if I look at Q or C, it's going to be using this side compared to this side. And we've talked about what tangent actually is. Back when we started tangent, we had that big old table. Tangent really gives us, this answer really is, what were we, when we initially started tangent, we were talking about degrees compared to, maybe I'm asking this poorly.
Wait, it looks kind of like wait, I don't know if this is at all what you're talking about, but that angle out there, it looks kind of like a in center, but on the outside. You know, because like it encompasses like part of the circle, like an arc.
I think you're going away from where I'm actually trying to get. You're not wrong, but I'm saying I'm trying to get you over here, and I think you're out here playing around, which is a good thing. I just want us to realize this at first. So, if I create an angle, and normally we're talking about angles going like this way, right? Like, so what if I have like a 45 degree angle? What do we know about a 45 degree angle?
It's a cube.
If I go to make a circle from here, and I make that.
Oh, it's a tangent line.
Oh,
So this that I said was 45 degrees would tell me that the radius of this circle
Is equal to the tangent line part tilde angle.
is equal to this tangent length. And if I reduce my angle size, then this relationship like still has to be true. So guys, the rule tangent actually relates to the relationship of the radius of the circle to the length of the tangent line from wherever that would actually hit to get to the tangent point. So if we draw like a legit tangent line and relate it to this angle measure that we're going to talk about, this is where tangent comes from. This opposite over adjacent. Opposite is really your radius. Adjacent is really the length of the tangent line to that tangent point. So this is where everything ties back around together. Trigonometry is not just dealing with triangles, it's dealing with circles and triangles and their relationships. I don't know if that makes any sense. It's beyond what we actually have to get you to learn, but I think it's very interesting to look at how all of this stuff relates to each other. Get out of here. All right, part B. I'll delete all that stuff once I can click on my keyboard.
Well, OR is 30 degrees.
Which means GB has to be 110.
Yeah.
And what side
And
is it?
little RGO is
It's 30 over 2.
13 degrees.
Yeah.
Yep. All right, what about C?
AC is the diameter.
Yeah.
Circle. AB is 16.
Or BC and wait, okay, what's the square root of 289?
So that's a
What's
tough one.
17? So 17 times
Yeah,
2
you're
is
right.
34, right?
What?
The diameter
Yeah.
is 34 units. And then AB is 16 units, and then trigonometry.
Yeah.
Wait, but we don't know if it's a right triangle. Oh, yes, we do, because it's a diameter and ABC
Yeah.
has to be at right angle.
Got it.
We need to find vector of angle A.
Okay, then do that. Wait, BC is just 16 squared plus 34 squared, or whatever that is.
16 squared.
Oh no, it's 34 squared minus 16 squared. Sorry.
34 squared minus 16 squared is 996 squared.
A is 61.93.
Is 30.
30.
Which makes sense.
30.96 is arc BC.
What?
What?
Arc BC is 30.96.
Are you sure about that?
How?
Yeah, I'm not sure about that.
I'm wondering if you're talking about arc A. Like arc BC looks bigger than 30 degrees.
Okay, so
Wait,
AC
arc or
Oh,
line?
never mind. Never mind.
So arc AC is 180.
Yes.
Arc BC is 123.86.
How would you get that?
Yeah.
I did the cosine function to get angle A, and then I used the inscribed angle.
Oh, okay.
Okay, what did you get? 120?
I got 123.86.
123.86.
And that is correct.
Great. So,
All right, so here's the deal. We don't need to move on to the next lesson because there's really no rush. For tonight, on your homework, you may skip 98 and 99, but I would like you to do the rest of them, and you can start right now, like with each other. So,
will we need a compass?
You shouldn't need a compass. Sorry, Connor. What'd you ask?
What's the 9 so much?
Skip 98.99.
Well, what's the like plus?
Oh, 10.24.